Well, hello everybody and welcome to the channel. My name's Tal, and in today's video I will be showing you the latest addition to the ESP NTP clock, which we built in the previous episode. So if you watched the first video, that's fine, continue watching this. If you haven't and you would like to look at the build, then you can find that in the description below, linked to episode 1. So far our existing clock uses hard-coded variables for the settings like the local Wi-Fi router ID and password, as well as other things like the time zone offset, the daylight savings time offset, and the clock works great, it works fine. But we need to program any changes that we might need if we move country or change time zone or even change the router. So you might be wondering exactly how we might address this issue, and frankly so did I in the beginning. But before we get into all that, let's take an overview of how we're going to address the problem. Okay then, so on the diagram in front of you, you can see a laptop on the left and you can see a clock on the right, and both are connected to some sort of Wi-Fi. This would be your normal house router. So in our anticipated solution, we would have the clock serving a page to a laptop. The laptop user would then put in the details and then press the send button and it would go back to the clock. So that's all well and good if your clock has actually got configuration for the current router. So if it hasn't, then you're not going to be able to do this. So that is the first question mark, and what that means is that the clock itself needs to act as a router. So that's what we do, and it's called a soft access point, which means we configure it and make it actually work like your router in the house does, except that it will give you no internet connection and the actual range will be very much more restricted than your normal router. So if you step outside your house very far, then you won't be getting a signal. So in this case, we'll set that up. We'll run a server so that we can push the page out to the laptop when it connects to it. So this will be on a different subnet to the normal subnet that you would have in your house. So normally it's going to be 192.168.1 and then whatever the number is, but with a soft AP we're going to set that subnet to 4, so it's different to anything else that's going on. When the laptop's browser requests a page on 192.168.4.1, then it will receive a page from the clock. It will render that page and it will also wait for a message, and that message will come from the clock. And that will be the configuration data, which it then needs to populate all the fields on the browser ready for editing by the user. Once they've finished editing on those details, then they press the send button. Socket is used to send data back to the clock, which is then stored in the EEPROM. So one thing to mention is that the web server and the sockets themselves are not secure sockets. I don't think this is a problem for these reasons. First of all, the soft AP is already secured with WPA2 security or WPA3, and there is no internet access from the clock onward, so the amount of time that you will be actually using this in this mode will probably be less than a minute, and as they would have to break into the soft AP, which would only pop up for a moment anyway, I think the risk is extremely low, and that the access point range is very limited and will not be available much outside the front door of your house. Then I feel that the threat model is a very low one, so I'm not going to do anything more at the moment. I might do it at some point later, but right now I need to get this video out. Right, so now we're looking at the overview of the system. So this tells you what's new and what was there before and where something has been modified. So as you can see in the title, it says include soft AP Wi-Fi provision to enable the config via Wi-Fi without needing to both log on to a dedicated router. So that's what we've just been discussing. Okay, so let's look at the new things. Well, we've spoken at reasonable length about the web server and the socket server in terms of their inclusion in this solution to the problem. So they've been encapsulated in a class there, and that class is called soft AP. And here we've got a new config class as well, and instead of having those hard-coded variables, now we've got everything stored in the EEPROM, and that's where we'll store everything. So this config class makes use of Arduino JSON document to store all of that data when it uses it, when we access it through the accessors, and when it sends it and receives it from the socket that it's been communicating with. So that's what's going on in there. We've got some changes to my display. The physical switch controls on the clock got now an extra push button, and when you push that down when you power on and keep it pushed down, then it will take you into config mode, and it will also allow you to go into normal operations once you've finished the config. The chip itself is just changed only really in its usage. Okay, so in this part of the video what I'm going to do is create a mock-up for this. So I'm going to create a web page. I'm going to put a head in there, and then we're going to get some script inside that head, because we're going to need some JavaScript to do things on the page. And then above that actually we're going to probably need some styling, because basic HTML looks absolutely rubbish. And beneath the head we're going to need the body. What I'll do is I'll put a heading in there or something like that inside the body, so I'll just do H1. I'll just save that and then we'll try and... there we go. So we've got the settings now. The next thing we need to do is to do some stuff in the JavaScript area. Well, we need some sort of initialization, don't we? So I have something in there. I don't know what I'm going to need in there at the moment. Let's go straight to the body and do some basic stuff on the body. So it's got some IntelliSense in there. Okay, that's good. Just to put our rows in there. Some of them anyway, at least the top row. And in there we're going to have 2 data cells. So one will be for the label. So a data cell there, and then a data cell there. Right, so what will that give us? Let's see what that does. So if I put in setting, and I'll put in value, well that should be a table header actually, not a table. So let's refresh our screen. Well, it's not very big, but we can sort that out later. And table body, then we're going to need some rows. You don't need any first row on that. And in the middle. And then we want to write something there like send. Okay, so let's get this looking a bit better, because this looks absolutely rubbish. So I need to put in some styling. So in this section I start doing some styling. I've sped this up tremendously because you would get bored out of your brain if you were watching me just type this all the time. So as you can see on the left hand side we've got the clock settings as it stood, with a table with no colours, no widths, no padding, no nothing. And there I go, putting all these in and then regularly refreshing it to see what the effect would be. And generally that seems to go quite well. As I might have said once or twice already in this video, I'm not using something with IntelliSense in really, or much of it. And so yeah, I'm struggling a little bit to remember all the attributes and stuff like that, but I finally get it all in and done, and we're just about to come up to the JavaScript section now. So I'll put an input in there. So we just put in an input, and then we can put some other stuff in there, like I could put a placeholder in there. We probably use something like, I don't know, europe.npt.org or something, whatever it is. As soon as we start typing in there, that goes away, so we can put our value in there. A little bit smaller text size, so I think I need to make that bigger. And we're going to give it an ID. And the ID is going to be in lowercase again. We'll make it all in lowercase letters there. So time, zone, offset. And then in there we need some options. So well, it will just be that. So that should show us 2 selection boxes there. What I would like to do is to set up a test function in here so I can test my page. That'll be the first thing I'll do. Right, and what I'm going to do with that, I'm going to use test page to actually pretend that we're receiving a message. So I'll create an empty object, and what we do, we'll say, right, data, and our first input is NTP URL. Yeah, so what I'll do is just finish off these items in here, so that we've got the NTP server, the time zone, and the DST offset, and then we can use those in the code. And then we need to do something with that. We need to work on this function here. I know we need this because we need some data, but we need to do this. So that's a test page. We also need another one actually. We need a function to set the data. Yeah, we need a function to set the data, and we can pass that something. So we need to put a JSON string. For our test page, when we press our button, we use the button to invoke this to begin with, and we'll try and make this work. So what I need to do here is to go JSON string equals JSON stringify data, I think. So that will take this created object and it will create a JSON string. Now the JSON string in this case is if it's been received. That's what we're testing to see. As it's been received, we need to then set these. Okay, so we're kind of building the functionality for the page here. So what I need to do there is to, okay, so we've got a JSON string coming in. So if I just put console.log set data, and then I want to say what the JSON string was. So at least if we go into console mode, we'd be able to see that. So we've done that, and then I want to create, I want to recreate this object basically. In this list of elements, or things that we need to fill in or fill that we need to set the value for, what we need to do is to create a method where we're not having to specify each one. These little data cells, if you like, in the JSON object here, we'll have the key and they'll have the value. Right, so we can use that to our advantage. So if we use a little for loop there, right, I'm going to put some semicolons on all of these because some browsers don't like HTML compression, and you will end up with JavaScript errors. So what we need to do then is to say document get element by ID. So that will tell us the key. That will select the object on the page, and then the value we want to set to JSON data, and again choose the key. Now that should, in theory, run through the object's data and it will populate all of the values with the key correctly. So on our button we need to call, so the button on click equals JSON test page, and we're going to have to put those escape. Alright, I think that might work, but I'm not 100% sure. So we've got that at our standard times, and it's absolutely not working. Alright, so let me pull these in. Let me see what I've got. Right, at pin 59, I've got a problem. 59. Good old console. That's 74, 73. That's 7314. 7314. Unexpected token. 7314. It was indeed. So that's incorrect. So now 85.3 we've got a problem. 85.3. Yep, that should have been. What is that? Why is that there? I'll put it in twice. Right, now we don't have a problem. So let's, okay, invalid settings HTML123 unexpected 125 123.54. I didn't like this. Oh, do you know what? I'm just going to do this. I'm just going to take this all out. Just for now. Oh look, in the console, it's actually... Why is it showing us that? But it didn't set anything. Is it saying I'm in test page? Console log. Going to take way too long. I'm in test page. So it is getting into the test page. It is... So it looks as if I forgot to set the data with the JSON string, so that's the problem. Okay, so do that, and then there we go. So that's our code, that will get us to that point. Right, so we need to write this in it. So on Windows load, I think, window on load, window load, no, on load, I think, on load equals init. init mate. So when the page is loaded, it will call this function after it's fully loaded, and then that's what will be over there. So in our init, we'll put in something like console log init mate. Just a bit of fun there. I'm in init mate. So let's see what happens. Does that actually happen? I'm in init mate. So I didn't call that function explicitly. That was called because the onload event called that function, and this is what happened. So now we're in there. What we need to create a socket. I think that's what we need to do. The window location dot host name. Well, in this case, that's going to be an IP address, whatever the IP address for the host is. So adding port 81, which is the default port, I think, for WebSockets. Let's just see if that's what we're actually getting, and that gives us any errors. Okay, 5210. It's got it didn't like no. 81 is invalid. Why is 81 invalid? Window.location.hostname plus, there's a plus there, WS is plus there, new WebSocket. So I'm going to go, maybe it's because it's not being served from the web. Possibly. Now we can test that out later, but I think that's probably what it is. Socket, as we're only in test at the moment. On message equals function. You receive an event from that. Okay, I think we'll leave it here for that because I think that's enough to get us going. Alright, so let's go over and set up our Arduino IDE project with this settings file as part of it. Okay, so we're going to write up the code now for our little test application, the Arduino IDE, where I've already set the board to ESP32 dev module and it's on COM3 in my case. We need to include the Wi-Fi, the web server and the socket server at the top of the sheet. So we created a page earlier, as you know, so we need to have compressed that, and we need to put it in somewhere so that we can use it. So I'm going to put a define in there. So when you're pasting in text like this, just make sure that you've checked for any quotes which are in the middle of the string. Otherwise, that will cause you problems. If you have got quotes, you need to put a backslash in front of the quotation mark to stop any problems. So next thing we're going to need to do is to create an instance of the web server. So web server on port 80 and WebSocket server. It's easier to just do this. And that's going to be on 81. Which is the standard port. And let's just see if that is going to give us a compilation issue before we go any further. So there are no problems there. So in the setup then we're going to need to start putting some setting up information in there. So this will allow, that line will allow us to print debug statements out, which will be quite useful when we're trying to debug the code if we need to. So we need to set up the Wi-Fi now, soft AP part of the Wi-Fi. So we'll just call it ESP32 clock. So that's the name of our Wi-Fi access point, and we'll give it password. Obviously we wouldn't use this in production, it's just for the purpose of testing at the moment. So the next thing we need to do is to configure that. Config, that's what I'm looking for. Right, okay. I'm not sure if it actually takes you any less time to do it this way. It kind of feels like it could be pretty close either way. So the local IP address is going to be, there are 5 different overloads there. We're going to use the 5th one, and that gives us the ability to write in octets. We'll just use commas and try and avoid putting in periods in the middle there, like I'm sort of inclined to probably do. So let's see. I did make a mistake. Look, I've done it there. This always happens to me. Let me do a quick compile. Yeah, so that looks okay. Not a problem there. Okay, so let's set up our config string. So after they do get the page, we can then send the config string through the socket to enable the page to use that data to actually set the controls on the page itself. This is the URL we're looking for, and that is the root, and then we need to tell it what to do. So there'll be a function there on the inside of this, an anonymous function. We're going to send some text. The text is going to be the web page. So web server send. Right, so it's going to be a 200 code, which is good. And then the type will be text. Right, let's get this right. Text. HTML. So that's the type. And then we're going to send the root settings page. Right, so we've already created the root settings page. That's what we're going to send. So let's just compile again, just to make sure. Yep, so that seems alright. So all that remains now really is to start the web server. And we want to add one more thing, I think. We want to add an event on event. So what we need to do here is respond to incoming text. So we need to set up a handler up here so that when the client has sent us something, that we can do something with it. And so this is the other half of the communication. So this is when somebody submits the configuration to the server, then we need to do something with it. So that's what this bit is all about. So the parameters will be the channel number first, and then the type of event, and then the payload, which is an array of characters basically, and then the length. So the events that we need to respond to are going to be the one where we've been connected, the socket's been connected, where we've received text, and all the other ones can just go to default. Looks alright, but I'll double check it. Let's compile it. Okay, so that seemed to work out alright. So what do we need to do next? Yeah, I don't know what we need to do at that at the moment. We could just say we're connected, so serial print line. So for the moment, let's just print a message there. Receiving text from client. Actually, and I'll put a couple of stars there to be conformative. So we're saying receiving it from the client, and then we need to do something with it. So as this is an array, probably what we want to do then is to print everything that we're getting in. So we need a little for loop. Well, that should do it, and maybe follow that up with let's just compile that and make sure that compiles. Okay, so inside the loop we're going to have to start off by putting a couple of statements in there to allow the web server and the socket server to handle their I/O and events. We're going to need to use the socket to broadcast the configuration to the client so it can set up the web page. So we need to go and define what config is. So we need another define up here. Config. Right, and here we're going to give it a JSON string with the data associated with the controls on the web page by their name as keys, and then the value that we want to set them to. So we're going to have a squiggly bracket at each end containing the object, and then for each one of these keys or values we're going to have those encased in a quote. Okay, so for each one of those internal quotes we need to escape those. Right, let's just check this NTP URL, anyurl.com, time zone offset 1500 for the value, DST offset 3600 for the value. Hopefully that's alright, but we'll give it a quick one of these. And now we're going to have to decide when to send that text. Well, we can't send it when we're not connected, and we can't send it if we've already sent it, because otherwise it would just repeat, and we don't want that. So I need to put an if statement in there, and in there is some condition, which we don't have yet. So the condition, we need some variables. I need to define those. So okay, let's go up here. Saying config already. That's something that we can use now, isn't it? We can take this and say when connected, we'll set client connect site 0 selected as true, connected as true. And right, let's go back down to our loop. So if is equal to false, and so once it's been through the loop, or the if statement I should say, and sent it, we then say that is going to be true. So that will stop it going through more than once. Is that going to work? So let's compile it. So that seems to have compiled. I'm confident that will work. Okay, so the only thing left to do, I think, is to test it. Right, so that's what we should do, shouldn't we? So let's compile it and send it up to the chip, the ESP32. Let's just do that thing now. Just clearing the serial monitor, and now I'm going to connect to it. I'm going to connect to it again. Alright, okay. Currently we're on 0 hours. I'm already in the console, and I'll load the page by refreshing it. As you can see, I've automatically received the data and it's set the controls to the right time. So you can see there we're in it when that was loaded. That was the IP address it was allocated. There's the received data. That was what we needed to set these controls. And that's the set data when it took that data and it set the controls. And those were the values. And all we need to do is to take a look in there. There's nothing in there except for socket connected. If we press the send button, we're going to send the current config back. So we'll send it, set it to GMT standard time, and nothing from what it was. So it was on this time zone there. GMT is 0, and it was on 3600. And we're now seeing that this is now set to that. And if we look in the serial monitor, you can see it's been received by the ESP32. Right, so this provides us with a basis for the rest of the design for the clock extension to enable remote configuration. So now we have done our mock-up to better demonstrate the intended use of sockets in this application. We're going to take a walk through the changes and additions to the code to get a better understanding of how it all hangs together. But before we go through that, we'll take a very brief moment to revisit the changes from a top level. And you can see on the screen there on the left hand side a very familiar looking form. As you can see, we've added some more fields here. So we've got the SSID for the router, and we've got the SS password for that router. That's not the soft router, that's not the soft AP password, this is your normal home router. The NTP server URL remains the same. We've introduced this sync interval, which is how many times a day we actually go out to the NTP server and sync the time to make sure we're as accurate as we can possibly be. We've also got a version number, which is something you don't fill in, but it's just shown there for your information. Apart from that, this form is exactly the same in terms of its appearance. On the right hand side, we've got a picture of our clock, which is in the beginning of config mode, so that's the instructions you're getting. You need to go and log on to this IP address which you can see here, 192.168.4.1. And that's what we've done on the browser. We've logged onto that, so this gives the user the instructions of what to do. And then here we've just got a representation of the fact that HTML is being sent to the client to be displayed on the web page. So that could be on your laptop or it could be on a phone browser. And then the transfer of data across the WebSocket or sockets. So we did get a view of this in the very beginning when the video started, but I just want to just very briefly run through again before we actually start looking at the code. So we've added a new class for soft AP which encapsulates all of that functionality, and we've also got a new class which deals with all the config, the storage and retrieval of data from the EEPROM. So that's permanent storage, which means it will survive a power off basically. So if you turn the unit off, it will still be there when you turn it back on again. We added a switch which you'll see later on, which puts us into the config mode, and made a couple of mods to my display to give you some of the dialog information that you just saw in the thumbnail with instructions for the user to follow. So that all being said, let's get into the code. myconfig.h. So this is the header file for that. So it's at this point we allocate the values that you'll find on the ID field of the controls on the web page to these keys. We've got something called a config number there. That config number sits in the first 10 bytes of the EEPROM. That will be saved as an int, so that will be 4 bytes. That is just a random number, and that is used to determine what to do if we don't find a config number. It means it has never been there, so we go and do something which you'll see later. At the offset point, that's where we start to store the configuration data. So above here we got Arduino JSON. That gives us a convenient way to serialize and deserialize and manage JSON data. Okay, so we've got a static JSON document there, and the config EEPROM config address is 0. Okay, so here's a bunch of declarations of the methods inside this class, and we'll explain those when we go to the CPP. So we're in the myconfig.cpp, and at the top we got the 3 headers there: myconfig, Arduino JSON, and the EEPROM, which is used to store stuff in the EEPROM, surprisingly enough. And then we've got the definition of those things I just pointed out in the .h file, the header. Clear the EEPROM just really simply iterates through that space, and it sets it all to FF. As credentials, it's saying if I haven't got either of these two things, then we haven't got credentials. Create a default config. It creates it without password and SSID because it couldn't possibly know that, and then it just puts some defaults, so that europe.pool.ntp.org, Central European Time as the baseline for the time zone. We've got 1 hour for that, and then at the moment it's version 1.0, and then we write that to the EEPROM. So conveniently, right below it we've got write to the EEPROM. Yeah, so this method basically serializes JSON, puts it into the EEPROM. Okay, so read config, obviously it's the polar opposite to write config, but the difference between this one and the other one as well is the fact that we're outputting a string, returning a string I should say. I will use that to send that serial data in the config to our page via the socket. Set config, that's why I explained to you about the stuff that's been, when you press the red button that says send or submit or whatever we put on there to store that config that we've got on the page, it'll receive that as a character buffer, and it just basically goes and puts it in the page, and then it says read the config, so it's put those in one at a time from the beginning, and then it says read that config into the JSON doc so you can again be able to access it. These are the 2 debug methods I said: the tabular form of displaying the settings, and the raw dump the EEPROM out to the monitor. And then we have all the individual accessors. So these are self-explanatory. We're just, from the JSON doc, we're just putting the SSID, or we're putting the password, or we're putting the NTP server. Time zone 1, so the same for these down here. The time zone 1 is a bit different, and it's a bit different because if you look at the long list of time zones that we're going to publicize in the drop down box, many of those values will be the same. So there's lots of places with the same time zone. So this is a convenient way for the user to look down the list, find out where they are, not have to worry about the time zone number, but to just know they're in Eastern Pacific time or GMT or European time, wherever it is. If we didn't do something about the fact that the values are all the same, then we would get a situation where a stored value would not necessarily select the right option, but just select the first one with that option. That's why the values have all got to be unique. So what I've done here is to create an index starting at 50 with a gap of 10 in between each number going up to the top number, and that basically gets us an order. So we append to that the sign and then the value. So the value held in each option in that drop down box is going to look like this. You're going to get the index number followed by a comma, followed by the sign plus or minus, followed by the value itself. So this code here splits that out and makes the appropriate adjustment and then returns the value. It's a bit clunky, but it does the job. So that explains how the myconfig.cpp works, and the main components are the EEPROM and the JSON document inside it. Okay, so we're now in the INO sketch file, the main file. The things that we've added to this that have changed from last time, we've added the config, which we've just been through, the soft AP, which we've yet to do, and we've added WebSockets. Most of them were there before, it's only config that's been added there. Now the DST switch has changed from pin 0 to pin 19. There's a push button now, and that push button is wired between ground and GPIO number 15, and that's what we use to make it go into config mode. Let me just go to the end and show you the difference in the main loop. The only difference in the main loop is that we've added this, which is checking for pin 15. If it's low, it will restart the ESP32. Now the significance of that is when you get into setup, one of the first things that we do, apart from those pins, is to say, okay, are we being asked to do remote config? And we check the pin to see if we are. So if that's low, it will say, I want the opposite to that, which is high. So we'll set that to yes, I want to go high. And then we've got an if statement there, and if do the config is there as a high, it will go into this loop. Also, if there's no config existing, which you know what that means now, and it doesn't have any credentials, or it doesn't have any credentials, it'll also go into the loop. There's an inner question mark here in this if statement. It says if there's no credentials or no config existing, I want you to do this as well, which is to clear the EEPROM, create a default config, and then write that to the EEPROM, and then continue to the soft AP. So we instantiate the soft AP server, the soft router that the clock is providing via its chip, the ESP32. We set the minimum security so that this is secured, and then we start the soft server. The switch that we use to get us into config is also used to get us out of the config. So at the end of the config process, when it's all been done, you'll get a dialog on the clock, which you'll see later, which says I've done the config, please press the push button. So when you press the reset button, it will restart the ESP32, and we put a little delay there of 1000 milliseconds, and the reason for that is if you leave your button pressed down for too long, it will reset and it will come back round and it will go back into config again, which is really annoying. So a quick press when you're exiting it, which you will see later, but I'm just mentioning as to why that is there while we're in this file. So yes, so that's it for the INO sketch file. Alright then, so we're in softap.h, which is the header for the soft access point class. So we got the page in there in the root settings. You remember this, most of this you will be familiar with. So we've got the soft router ID and the soft router password. So here's the constructor to which we pass a display object which we'll need in the class. And then in here, publicly available within this class, you've got my screen, which is of that type. So in the softap.cpp, that will get initialized. And this is just a debug message thing, which I don't think I've even used, but it's there. And the send socket event. So if we go into this over here, still got the headers up there, so you can just read that for yourself. We've instantiated the web server and the socket server like we did before. So ap-config is actually just a pointer to the display class, so the config class, which we'll need to use within this class. So these three balls are used basically in control, the main loop further down, which means we don't send the config more than once, and we're connected when we do it. So there's our constructor, so that's what I meant. We pass the display to it, and we've got it available to us internally. Then we do a TFT setup and clear the screen, so it's ready. We've talked about that. Let's just print in a debug message, and we've also talked about this. And you'll remember we set this in the loop, which you'll see again in a minute. After sending the config to the web client, this line will prevent it being sent again. So a WebSocket event, you know about this already. We've done this before. What's different here is we're not just printing it out. We're calling the set config, which we explained a little while ago. We're giving it the payload from here, and it's going to put that straight into the EEPROM, and then we'll display the settings only really used for debugging, and we'll do that as well. We'll dump the EEPROM. If you want to take those out, that's fine. It doesn't matter either way. It's going to be okay. And then we request a reboot. So that's significant. So once you've received that, you do all those things, and then you ask the clock to reboot itself. So then it will come up, and it should just work, providing you put the right information in there. The code in this start server method is the same as what you saw in the loop in the test rig. So we've set up the web server. We've printed out the IP address on the clock's OLED display. We've set up our on-request action, which will be to send the root settings page to it. So that's the HTML that will go down. We'll begin the server, begin the socket server. We'll set up this event handler, which is this one. And then it will say, well, we've started, displayed the settings, and we dump the EEPROM again, just for debug purposes. And again, you can take those out if you want. And then it will run this loop while it's in request reboot. So these two lines cause the web server to handle the client, and also cause the WebSocket server to handle its I/O. So next up is the if statement here. So this is checking to see if the socket is being connected, and if we have already or haven't already sent the defaults. It won't let you in if you've already sent them. So what it's doing is going to get the EEPROM configuration via the ap-config, and then it will put that into the broadcast text method here, and it will send it. Set default already sent to true, and then print out a line to say that. Okay, so this outer loop is predicated on the fact that it hasn't been asked for a reboot request. If it has been asked for a reboot request, at that point it will exit the loop and go on to the next stage. And at this point it will display the reboot instructions on the clock OLED display. And it will remain in this little loop waiting for the push button to be pushed down and get a low on GPIO number 15 pin. And once it has that, it will restart, and it will ask you to press the button to exit the loop. So it will go through this loop repetitively until you press the button. Once it goes through there, it will restart the chip, and it should just come up and work fine. So that explains the soft AP functionality. Any commented code will be removed, and any unused variables also. So the last thing to do is go and look at the settings page before we do the demo. Right, so this is the very last file we're going to go through, and it's a simple one. It's just the settings.html file. So I want to very briefly go through the changes. So in the styling, nothing's changed. In the code side of things, we've got the socket now taken out of the init function and put into the main body of the JavaScript code, so it's available elsewhere. And I've added this small method which allows us to actually display a reboot message to the user once they press the send button. Now let's go and have a look at what's happened in the main body of the HTML. Obviously we've added the SSID and SS password there. We've also added the NTP sync interval. As you can see, there's a selection of values that the user can choose from, and this is the huge, well, not huge, but quite large list of time zones around the world. And as you can see, if you look down this list, you'll see duplicates there, the same values you can find in different places. As already explained, we had to create an index which was also a unique key that still contained the value that we wanted to see, and so that's the main difference there. And also in the last but one row, we now have the message that gets displayed to the user. So say rebooting clock, check clock display. So that gives you an opportunity to go and look at the clock display and see the dialog that tells you what to do. Let's get on and do the demo. So we finally arrived at the demo section. So what I'm going to do is just show you on the back of the clock is the little white button, which is the restart, puts us into configuration mode. You might remember from when we were discussing it in the code, when the clock is showing and everything's just moving along as normal, holding that down will reset the clock and put us into configuration mode. And as you can see, it's saying set the laptop Wi-Fi to ESP NTP clock and then browse to this number 192.168.4.1. So that's what we're going to do. Connect to the NTP clock, and in the browser I've got 192 already there, and it's showing you the settings from the clock. We're at europe.pool.ntp.org as the NTP server that's in use. GMT every 12 hours, 1 hour DST offset, which isn't applied at the moment because it's winter time. And now I want to make some changes, so what I'll do then is to alter this as a simple test. So I'm going to go to Arab time, which is 3 hours ahead. So at the moment it's 11:47 AM. And I'm going to submit this and let's see what happens. Right, you can see the message has been displayed on there that it's been saved, rebooting clock. Well, we're not quite at the reboot at the moment, but we've got the dialog on the screen. So as you can see there, it's saying set the laptop back to whatever you want, regular Wi-Fi, push the config button to reboot the clock. So we just have to push it once and off it goes. And we should see this come back up, and it should show Arab Standard Time, which is going to be 14:48, which is 3 hours ahead. So that all works. Wonderful, isn't it? So what I'm going to do, I'm going to put it back in config again by pressing the button. Let's just check that the connection hasn't dropped off, because it probably has. So reconnect again. That's probably about enough time for it to have done that now, so I'm going to refresh this here. You can see that the config that was stored on the ESP32 EEPROM is now back up there. So we'll do one more thing. We'll set it back to GMT because that's where I want it, and we'll submit that change and then just click to reboot. Alright, so we're back now to normal GMT offset, which is 0, and everything seems to be working absolutely fine. So this video was quite a bit longer than I anticipated at first, but there was actually quite a lot to cover, so it was quite difficult to even cram it into the time that we had. But there's more to come, but not in this episode. So in episode 3 we'll be covering auto daylight saving time, which means you'll eliminate the requirement, if you want, for the switch between daylight and summer twice a year, but that will still be available if you want to use it. An additional alternative power source required by a future upgrade yet to be done, not in the next episode. But in the next episode there will be a mystery upgrade which is as yet undeclared. So I hope you've enjoyed the video and I hope you found it informative. And if you have, please hit the subscribe if you're not already a subscriber, and hit the like button because that really helps. With that said, I thank you very, very much for watching, if you stayed to the end, which you must be because otherwise you wouldn't be listening to what I'm saying. And I will see you next time.